All right, here we go. First video on the brand new laptop. What could possibly go wrong? This is our Unit 9 test review. All right, so this is going to be next week. Um, let's see here. Know the formulas for squares, rectangles, circles, triangles, trapezoids. All right, so all of those area formulas. So those are going to be some things that you should know. I do give you a formula sheet. I don't remember exactly what's on it, but just in case I forget something, just make sure you know all those formulas uh, for areas for sure. All right. And volumes for prisms, trapezoids, pyramids, cones, spheres, circles, all the good stuff. Everything that we've talked about in this unit's fair game. All right. Anyways, moving on. Number one, given a rectangular convex, good start. Given a regular convex polygon with each exterior angle of 15 degrees. Determine the number of sides in the measure of each interior angle. All right, so we're going to start off by saying we have some exterior angles. Now, I know if I take every single exterior angle and I multiply it by the number of sides, that is always going to equal 360 degrees, no matter what shape. All right, anytime you have a regular polygon, that's going to happen. So now they're saying every exterior angle is 15. So we can say, all right, well, 15 times n equals 360. Therefore, what are the number of sides? We know n is just equal to 360 divided by 15. All right, whatever that number is, I don't know what that is. 360 over 15. 24. All right, so this is a 24-sided shape. I don't know what that's called. It has 24 sides. So that was part one, determine the number of sides. And then part two, the measure of each interior angle. All right, this one, very simple. I know the interior angle plus the exterior angle, just one of them, just one interior plus one exterior equals 180 degrees. Therefore, since that exterior angle was given, so I can say the interior angle plus 15 equals 180. All right, so to subtract 15 on both sides, we know that interior angle equals 165. All right, so that's number one. One down, a lot to go. Given a regular convex dodecagon, determine the measure of each interior angle and each exterior angle. Dodecagon is a 12-sided shape, so we know n equals 12. All right, determine the measure of each interior angle, determine the measure of each exterior angle. So there's multiple ways to do this. I know if I take 180 times n minus 2, that's going to give me every single angle added together inside of the shape. All right, so if I do that and I divide it by the number of sides, that is going to give me just a single interior angle. All right, so I'm going to do 180 times 12 minus 2 all over 12. Simplify that a little bit. 180 times 10 over 12. I don't know what that is. 1800 divided by 12. That's 150. All right. And again, I can use the idea up top from the supplementary angles. So since the interior angle is 150, that means our exterior angle has to be supplementary, so that'll be 30. All right. Another way you could have done it is we could have said, all right, exterior angle 360 divided by 12. That also gives me 30. That is an exterior angle, and then you can work backwards to get the interior angle. All right, so that that part on the purple there, probably the faster, the easier method. But this formula, right, that's fair game. You can also use that one if you want. All right, next one. Moving right along, the measure of each interior angle of a regular polygon is 8 times that of an exterior angle. How many sides does it have? All right, so this is one of those word problems where we just have to kind of put it all together. So let's see here. The measure of each interior angle. Each interior angle. That is 180 times n minus 2 all over n. All right. Of a regular polygon is, anytime you see the word is, that's your equal sign. 8 times. All right, so I'm going to put an 8. 8 times something. 8 times what? 8 times the exterior angle. That of an exterior angle. So one single exterior angle, that is 360 divided by n, divided by the number of sides. All right, so that is what our setup looks like. There's a few ways that you could do this. I'm going to cancel out the n's and the denominators. I'm allowed to do that because there's just a single fraction on either side. So I got 180 times n minus 2 equals, let's see, I get 8 times 360. All right, we can distribute that. I'm going to divide both sides by 180. That way I have n minus 2 equals 8 times 2. All right, 360 divided by 180 is 2. So we have n minus 2 equals 16 thus. N equals 18. All right, so that's an 18-sided shape there. All right. Number 4, determine the sum of the interior angles and the sum of the exterior angles of a 20-sided convex polygon. All right, this one's not so bad. Sum of the interior angles, that's 180 times 20 minus 2. That's, I don't know what that is, 180 times 18. I don't know what 18 times 18 is, so I don't know this one. So 18 times 180, 3240. All right, so if I take every single angle on the inside of that shape and I add them all up, I get 3,240. The sum of the exterior angles. All right, this one. This is a free question. The sum of the exterior angles. That's all I need to read. All right, it does not matter how many sides that thing has. It's going to add up to 360 no matter what. All right, and that one's done. Number 5. Lots of problems. All right. Determine the base of a trapezoid whose area is 32, one base is 6, and then the height is 4. So if we were to draw out a trapezoid, right, because I don't know if I like this new computer. The base of trapezoid whose area is 32. So I'm just going to say like A equals 32. One base is 6. So I'm going to call this base my 6. I'm going to call this height 4. All right. I know the area formula of trapezoid, and you should too. That's equal to base 1 plus base 2 divided by 2 times your height. All right. We know the height. We know a base. We don't know the other base. So I'll call this guy base 2. I'll say that's the one we do not know. And let's plug everything in. So we got 32 equals, how about 6 plus B2 all over 2. And then we got to multiply this guy by 4. All right, so doing a little bit of algebra, I'm going to skip a few of these steps here. I'm going to say 8 equals 6 plus B2 all over 2. Then I'm going to say 16 equals 6 plus B2. Therefore, we got B2 equals 10. All right, B2 equals 10. All right, so what I did is I divided both sides by 4. Then I multiplied both sides by, then I multiplied both sides by 2. Subtract the 6 over, I got a 10. That's left over. So, always draw pictures when you need to write the formulas out, right? So what are we working with? We're working with trapezoids, so write out the area of the trapezoid formula, fill in what you know, all that good stuff. All right. Determine the area of a circle that is outside the regular hexagon inscribed in the circle with the side of 8 centimeters. All right. Determine the area in the circle that is outside of the regular area circle that is outside. All right. There's a lot going on here. I'm going to need a picture. So I have a hexagon and I need a circle now. Where's my circle? All right, it's gonna look something like that, I think. All right, so if I'm interpreting this correctly, they want to know this area right here. All right, so let me go back and just kind of double check that. Determine the area in the circle that is outside of the regular hexagon inscribed in the circle with a side length of 8. All right, yeah, we're good. So we know that this side length right here has a side length of 8. All right, so that means all of them have a side length of 8. What I'm going to do is I'm going to put a dot right in the middle. What I need to do is I need to figure out the apothem. All right, so I know the area of this hexagon is equal to 1/2. Oh, let me try that again. Is equal to 1/2 AP. All right, so we have to figure out the apothem. Now, if I look at just this triangle here, right, I actually know what kind of triangle that is. I can figure out this entire angle right here. That is a central angle. So that central angle is 360 divided by 6. There are 6 sides to this shape, so that's just 360 divided by 6 gives us a 60-degree angle. So that entire angle is 60 degrees. What I'm going to do is I'm only going to focus on the left side, that pink kind of triangle. So this angle right here is 30. Right? Since we have an apothem, that's a 90-degree angle. This is a 60 right here. This entire side length was 8. So we chop that in half and call this a 4. And now we have a 30, 60, 90 triangle. So that's going to be something that you guys need to know. We've been using these things for months now, so you should be able to identify this one. So we're going to get a 4 and an 8 right there. All right, so we have a 4, square root of 3. We have an 8 on the radius, and that's everything we need here. So the area of the hexagon is equal to 1/2 4 square root of 3. Let me try that again. 1/2 4 square root of 3 times the perimeter. We did not find the perimeter. We can get that one very quickly. We know the perimeter is just equal to the side length times the number of sides. 6 times 8 is 48. And so we'll go 48 over here. All right, you throw all that in your calculator. I got 1/2 of 48, and then I got to throw a 4 on there. That gives me 96 square root of 3. That's the area of the hexagon. That should have been an H. All right, so that's the area of the hexagon. All right, now we need the area of the circle. The area of the circle, that's easy. That's pi r squared. We found the radius, right? This guy right here is the radius. So pi times 8 squared, that gives us 64 pi. Right? So kind of that red shaded area there, I'm going to say S for shade, is just equal to the area of the circle minus the area of the hexagon. All right? Which that number right there, 64 minus 96 squared root of 3, that is an exact answer. All right, so if you leave it just like that, that is the most accurate answer that you can get. If you do want to get a decimal, just throw that all in your calculator, and that's going to be 34 point, how about 79? We'll call it 0.79. All right, I got 785. That'll round it up to 79. All right. I don't know what the units are in that, so maybe it's centimeters, inches, but it's an area, so it's a square unit. All right, now the last one. Find the volume of a cone whose height is 10 and base area is 16. So we need a cone. All right, so this guy right here is 10. And we know area base is equal to 16 pi. All right, I didn't even need that picture because the volume of a cone is equal to the area of the base times the height divided by 3. All right, we know the area of the base, so they pretty much just gave this one to us. This is just going to be 16 pi times 10 divided by 3. All right, so that gives us 160 pi over 3. Oh man, guys, what is going on with this thing? 160 pi divided by 3. All right. I don't know what that is. 160 pi over 3. Type that in your calculator. Again, that's 167. 167.55. All right. But that one's done. This first page, that went relatively quickly. So I got to fix my computer because something's up with it. So we'll see you guys in the next video here.